In Lesson 12.2, we're going to look at experimental probability. And experimental probability is the probability of an event occurring given a certain number of trials. It's what actually happened. Not what should happen. Okay, so let's say you toss a coin. If you toss a coin 6 times, theoretically 3 of them should come up heads and 3 of them should come up tails because you have the same chance. But if you toss a coin 6 times, 5 of them could come up heads and 1 of them could come up tails. That would be the experimental probability. What actually happened, not what should happen. So let's look at some examples. A manufacturer of computer parts checks 100 parts each day. On Monday, 2 of the checked parts are defective. What's the experimental probability that a part is defective? So there were 2 defective parts out of 100, which reduces down to 1 over 50. So the experimental probability on that day was 1 out of 50 parts. That doesn't mean that's going to happen every day. That's just what happened that day. Okay, so let's try the next one. Which is the best prediction of the number of defective parts in Monday's total production of 1250 parts? Well, the experimental probability that we got was 1 out of 50. So how many would that relate to out of 1,250? So I know that 50, so if I solve this, 50 goes into 1250 how many times? Let's try 25, 0, 25, 0, 0, 10. Oh, look at that, I get 1250. So if I do times 25 here, then I have to do times 25 on the top. So x equals 25. So you can predict that 25 parts out of 1,250 will be defective. So the correct answer is choice B. Okay. So now we're going to simulate an event. A dog breeder knows that it's equally likely that a puppy will be male or female. Okay, so half of the dogs should be male and half should be female, but that's not what actually happens. So use a simulation to find the experimental probability that in a litter of 4 puppies, all 4 will be male. So to fill this in, what they did is they tossed a coin 4 times. Or they tossed 4 coins at the same time. Okay, so we're simulating 4 coins at the same time. So male and female puppies are equally likely to happen. So they said heads was a female and tails represented a male. And so they did this 16 times, tossed all 4 coins. So in the first time, 2 came up heads and 2 came up tails. And in the second one, we had 1 tails and 3 heads. Third time, they had all 4 tails and no heads. Okay, so these are just different things that would happen. So the probability that there's exactly 4 males, well, here's the male, here's 1. Any others? Nope. So I got 1 out of 16. So the experimental probability that in a litter of 4 puppies, all 4 will be male is 1 out of 16. Okay, so you're going to try these quick checks. In 60 coin tosses, 25 are tails. Find the experimental probability. Number 2, use the data in example 1. Predict the number of defective computer parts in a batch of 3,500. So you're going to do a proportion again. So it was 1 out of 50 should be the same as how many out of 3,500. Solve that for x. Use the data in example 2. So that's the puppy chart. What is the experimental probability that exactly 3 of the 4 puppies are male? Okay, so count up how many times that happened, put it over 16, and reduce it if need be. I'm going to check your work in class.